conversation, but you know, that's me. Let's start with finding derivatives of some more polynomials. So in this case, we're moving on to the weirder ones. So in this case, this is a version of question 18. You've been asked to differentiate that. Now you might think, what about this A, B, and C? We call them constants. Mathematical term for them is constants. What that means, it's a number, right? You might not know what the number is, but you know it's a number. And we call, in this case, Z, the variable. So you can see here, that's the variable. This is Z squared. This is also Z squared. Now, if you wanted to differentiate this function, your first job is to write it as a power of Z. So what I'm going to do is this is not the only way to do this, but I'm going to call it that guy, and that guy. So this is the first way to do it. I'm going to show you two different ways algebraically to get to the same destination. This guy can now be written as AZ to the negative 2 power. Would you agree one of the Z's gets killed, but there's still a Z on the bottom? So this is BZ to negative 1. And since all of these get done, you get that. Are you comfortable with how this fraction now became these various powers of Z? Are you comfortable with what I just did there? Right. Now, I said there are two ways to do that question. I'll show you the other one over here. What you do is you take the numerator, oops, that's a Z, take the numerator, which is this guy, and you multiply by Z to the negative 2. And if you do that, you get AZ to negative 2. That and that, when you combine them, gets you BZ to negative 1. And when you combine these, technically you get CZ to the 0, which is just C. So do you see that that's just two ways of looking at the same question? Right, how about finishing the question then? Well, you differentiate, and it's a power rule. As long as you can write them as powers, it's a power rule. Multiply by the power and reduce the power by 1. Multiply by the power and reduce the power by 1. And too late now, and plus 0. Would you agree that if you differentiate the letter C, which just represents a constant, right? A number, isn't the derivative of all numbers 0? Now, I can get away with writing that 0 there because we're not finished. Don't we have style point rule to worry about now? Which in this case is basically make everything look like a fraction. So this guy is going to be 2a over Z to the 3, take away b over Z squared, and that is the end of the question. Let me check here. Oh. So far, so good. Right. We have a few more of these guys to do, and then we're going to move, well, not few, quite a few now to look at it to do. And then hopefully we'll get to move on to the next section, either at the end of today or definitely by tomorrow. Now this question, I'm only going to take it to the point where we could differentiate it. Right, that's the guy that we are going to differentiate. To differentiate that guy, don't we have to rearrange it, write it in a way that allows us to differentiate? Right now, it ain't any good. Now, I've shown you two ways to do this. Pick either way that feels comfortable and tell me what I should do in my next line. How could I rewrite that? Any ideas?
You break up to make the cube root of v into v to the 1/3 over v minus 3v e v over v, and then just cancel the v on the right and subtract the v on the left to make it v to the negative 2/3.
You comfortable with that? Do you see what you did there? Nailed it, Nick. That's exactly what I would have done. Now, can you also, if you wanted to, and get the same effect by bringing this upstairs and multiply through by v to the negative 1, and you'd get to that way. So that's the two choices that we're given. That's as far as I'm taking this one. Again, the next one, I'm only going to take it to the algebra stage. It's another one of these ugly fraction things. And I am going to give you a little bit of a help. I'm going to call the square root of half. How are we going to, like we did here, get it to look like that? Now, how are we going to take this one and get it into powers? Come on, don't make it Nick's job. He's got plenty of things he needs to do too.
Okay,
Right.
multiply 1 over w to the negative 1/2 times the numerator.
Okay, so I'm going to take the numerator and I'm going to multiply it by that. Okay, that's what I think I heard Rachel say. And then this guy is 2 take away half, which is 3 halves. This is 1 take away half, so that leaves me with a half. And this guy is negative half. Build it. Couldn't you use the power rule on that and then make it look pretty? Now, once you've seen 2 of something, I always think you need to see 3 of something before it becomes a little bit clearer. So I'm going to have to make one up because we ran out of choices there. So this is just a pretend question, one that I've made up. Okay. 2 different methods, both work. If we did it with Nick's method, wouldn't we split that as a 3x cubed over an x and so on? And if we did Rachel's method, wouldn't I multiply the numerator by x to the negative 1, right? In fact, if putting a 1 in there helps you visualize it, that's fine. Okay. Great. Anybody who wants to chuck in what we should do in the next line by whichever method they prefer?
You can do 3x cubed divided by x minus 4x to the 1/2 divided by x.
Do you notice she did exactly what you should do? That she changed the square root into a fractional power because you need it that way. I'll do the rest for you. I'm sure you know it, but 3 take away 1 gets you x squared. A half take away 1 gets you x to negative a half. Would you agree that is now good to go for the power rule? And if you do, 2 or 3 lines later, you would get that one. Okay, let's look at the same questions, not necessarily the fraction ones, but questions that ask this. How to find the equation of a tangent line to a curve at a given point. So you're going to get a question where they'll tell you f of x equals whatever it is, and you're told that there are point in the curve P at 1, 3, whatever that might be, right? And your question is to find the equation of the tangent line. So imagine that they gave me a function, y equals f of x. And at this point here, is P. And P, there is a tangent line. You agree it's probably that line, right? We're being asked to find the equation of the tangent line. Now, before we do that, I want to remind you of a piece of, a formula, a piece of information you're going to use. If you have a point 1, 3, and you know the slope of that line is, say, a half, you can find the equation of a line that passes through a point with any given slope. And the formula is y take away y1 equals mx take away x1. Can you hear a little horn sound? Chloe has found her squeaky, what do you call it, pig. That's, come here. Here it is. And now it's in there. Let's see if she can find it. So we've got this guy. So in this case, it would be y take away 3, because this is called y1, equals a half x take away 1. And distribute the halves. And then add 3 to both sides, in which case 2.5 is called 5 halves. And typically, that's the format that we would expect you to write the equation of any line in, right? In the format y equals so many x plus or minus a fraction, right? That kind of form. So here is our first example of that question, and it's a nice polynomial, and I'm going to use Desmos at the end. So the function, this is question 21. So it's 2x cubed take away x squared plus c, and we're being asked to find the equation of the tangent line at 218. So you want to find a derivative, you call it y dashed, right? So normally when it's fx, don't we call the derivative f dashed of x? But if the formula says y equals, we just call the derivative y dashed. You're comfortable with notation? That means derivative. So it's a power rule, multiply by the power, reduce it by 1, multiply by the power and reduce it by 1, and you get nothing for that. Won't the slope of the tangent line be the value of this at x equals 2? So the slope of the tangent line is 6 times 2 squared, take away 2 times 2, which is 6 times 4, which is 24, take away 4, which is 20. And the equation of the tangent line, then, we will get it by using this formula. And this guy's going to be x1, and this guy's going to be y. So it's y take away 18 is 20 x take away 2. Y take away 18, distribute the 20. If you add 18 to both sides, I believe you get that. And there is your answer. In WebAssign, they already give you the y equals, so all you need to do is fill in the bit that goes there. Just in case you don't notice it, and then put a y equals inside the box, because then it will tell you you're wrong, right? So if you wrote this, because you didn't notice that, WebAssign's going to say, wrong, right? It's nitpicky, but just to save you a whole load of grief, right? Because it's easy to miss it. Now, I promised you, and hopefully I'll be able to keep that promise, that we should be able to check that on WebAssign, Desmos. So, have we picked on the French lately? Did I pick on any of the French? Okay. How many Frenchmen does it take to defend Paris?
We said this one.
I did, so I have picked on the French. Okay.
It's been a while, but yeah.
Oh, okay. How do you sink a French battleship? You put it in the water. Oh. What's the difference between a Frenchman and a frog? Some people like frogs. Okay. Has anybody here got French ancestry? Because I'm in real trouble. Okay, nobody is willing to admit it after all that. So here goes. Here is Desmos, and I'm going to put in the original function, the cubic curve. It looks something like this. So it's, I believe it was 2x cubed, take away an x squared, and then it was add a 6. Oops, add a 6. Interesting shape. And the tangent line was y equals 20x, take away 22. And we were interested at the point 2, 18. So if I go about here, whoa, it's a bit hard to tell. If you look at 218, can you see that the curve and the straight line merge? And then if I drift out a little bit there, I don't know if I've convinced myself. Can you see the curve and the straight line are tangent lines? The problem is that the curve is so linear looking, you can't really tell well, right? But I can definitely tell when I'm wrong.
You can,
suppose
you can click and drag at the point and see like the little, right there, yeah.
Oh, yeah, at this point, and,
Yeah.
and drag it to, oh, it's on 218.
Yeah.
And what can I do now?
Well, it just shows you that is the point where
Oh.
there.
So it kind of knows, even if you can't see it, that the tangent line is there. Now, if I made a mistake here, suppose I thought the answer was 12. Would you agree that at the point of interest, which is here, they are definitely not tangent lines, right? And if the mistake I made, which I tend to make more than other mistakes, is I thought it was negative, would you see that isn't even a vague chance that at that point there anything interesting is happening, right? So you could certainly put it into Desmos and check it out, and it's a good way of visualizing it as well. So let's return back and look at another example, if I can. Okay, where the heck am I? Have I lost my picture? Why? Anybody know why I talk to myself? No. It's the only way to have an intelligent conversation. I'll go on. That's a good one. Yeah.
I'll have to tell people that whenever they walk in the room when I'm talking to myself.
Some people are auditory learners, and all that means is that they like to hear things, right? So they don't like reading books, but they love audiobooks, that kind of person, right?
Oh, yeah.
Yeah. So very often that type of person will read out loud because it helps them understand what's going on, and they read out what their working says because that also helps them. So I totally understand where you're coming from if you do any of those things, Teresa.
Yes, I do.
And there is nothing wrong with that. It's a totally normal way. The only time you should get worried if you start arguing with yourself, then you should have a problem, right? So if you hear answers, it's a problem, and if you argue with yourself, it's a problem. But apart from that, it's totally natural, and I do it as well. So, although I think my job kind of makes me do it as well, doesn't it? Because because people are auditory, I like to say what I'm doing because it helps them. They want to hear me rather than see me, right? Some people are visual learners, although everybody's a bit of everything. A visual learner, which I am as well, likes to see pictures of things, right? They like drawings of what's going on. Even if it doesn't help you with the answer, it helps their understanding. Oh, that line is going to be a tangent line. If I do it right, it's going to meet the curve at that place, right? And that helps reinforce what they're doing. Right, let's do this fella. If you differentiate 2e to the x, I know we haven't done many of those, but it is my favorite thing to differentiate. What do you get if you differentiate 2e to the x?
2e to the x.
And plus 1. Are we all comfortable with that?
Yep.
So you want to find the slope of the tangent line at an x coordinate of 0. So m will represent the slope of the tangent line. Be careful. Most people are good with this, but sometimes you forget. E to the 0 is actually the number 1, isn't it? It's not 0, it's a 1, right? So this is 2 times 1, add 1. So the slope is 3. And now we can go y take away y1, m, x take away x1. Y take away 2 is 3 times x take away 0. And y is 3x add 2. That worked well. I'm looking for some. I think I've actually killed it, unfortunately. Oh no, I got it. Okay. Let's just one more time. Let's look at that in Desmos and see, what it visually would look like. So I'm killing that guy off, and I'm going to go 2e to the power of x add x, and I'm going to kill that off, and it should be 3x add 2. And shouldn't we be interested at point 0, 2, right? So let me shrink that guy back. Oh, that is a much cooler one, right? If I zoom in a little bit more. Oh yeah, I wish I'd done this one, the first one. Would you agree the blue line is a really good tangent line at 0, 2 to the red curve? You see that? It nailed it. So if you're doing a test, where you don't know what the answer is, couldn't you just grab up Desmos and do a little quick sketch? And if everything looks good, you should be really comfortable about the answer. And if the answer looks wrong, which I'm now going to put in wrong, can you say you would look at that and say, at the point 0, 2, I should have a tangent line. How come you're not over here? Do you see that tells me I've done it wrong? And, hopefully you can go back and look at your working and see where the error happened. And where the heck am I? I'm here, right. Moving on to, oh, darn it in space. You think by now I'd be good at switching between one window and the other, but I'm not. Are you comfortable about the process that we're doing right now? How to find the equation of a tangent line? The derivatives haven't been too bad, right? And the y minus y1 is kind of fixed. You use it all the time. So I'm trying to see if I can find something a little bit different. But yeah, okay, this one's a little bit different. And this is a version of question 27. So we have y equals x to the 9/8, and we're interested in the point where the equation of the tangent line meets at 1, 1. And the derivative is 9/8 multiplied by the power, take away 1. And if you take away 1 from that, you will get 1/8. Agreed? 9/8 take away 8/8, right? You get 1/8. Yeah, I can leave it like that. If you want to find the slope of the tangent line, then it's 9/8 times 1 to the power of an 8. What number is 1 to the power of 1/8, which is just the 8th root of 1?
1 times 10 to the power of anything is 1.
Okay, so are you happy about the answer being 9/8? It looked weird, but calculation wise. If you really weren't 100% sure, couldn't you go to your calculator and just say 1 to the power of, and then make sure you put it in brackets, 1 divided by 8, and then hit the button. You see it's 1. If you really weren't sure. Now, y take away y1 equals m brackets x take away x1. And that is y take away 1 equals 9/8 x take away also 1. Distribute the 9/8 and then add 1 to both sides. Are we comfortable with that? Now, that is called a tangent line, right? In fact, it's the equation of a tangent line. I'm now going to show you another guy. It's called the normal line. And we're going to find the equation of it. So, can we just pretend that that guy is a curve that looks like this? Actually, it probably will be a curve that looks like this. And at 1, 1, we have P. And the guy that we've just found, the tangent line, looks something like that. Are you comfortable that that's probably what that's going to look like if you put it in? And we call that a tangent line, right? There is another line called the normal line. And the normal line is this line here. And we're going to find the equation of that normal line. And the normal line has the property that it's at right angles to a tangent line. So can you imagine this pen is a tangent line? Wouldn't this blue pen be the normal line? Right. Imagine that's a tangent line. The blue guy is my normal line. Normal lines are quite interesting because normal lines very often tell you the angle at which something bounces off something, if you're interested. So I need to know only one thing to get the equation of a normal line. I need to know the slope of the normal line. I already know the slope of the tangent line. In this particular case, the slope of the tangent line was what, 9/8. To get the slope of the normal line, I'm just going to tell you how to do it. I'm not going to give you any great proof to it, but it is -1 over that guy. In other words, turn this guy upside down and make him negative. And if you turn this guy upside down and make your answer the negative, you get -8/9. Are you comfortable with what I did? Even if you can't say, why did you do it? You can understand what you do. Does that make sense? So here's the reasoning behind it. There is a property that I hope you've met somewhere, which says if two lines are perpendicular, that just means they make a right angle. When you multiply their slopes together, don't you get -1? Has any of you ever seen that property? That the slopes of two lines that are perpendicular multiplied together always give you the number -1. Now, if you rearrange that then, doesn't that mean that the second slope, i.e. the tangent line, is -1 over the first one? And that's what I was doing there. Sort of a proof using some you might have heard. Right. Let's put it together. I want to find the equation of the normal line. It's going to be y take away y1 equals mx take away x1. The only difference is that the slope will be a different number. So in this case, it's still 1, 1. So it's y take away 1. The new slope is, right, turn this guy upside down, right, 9/8, and make him a negative. So it's -8/9. And distribute. That times that gets you +8/9. If you add 1 to both sides, you are going to get -8/9 x, add another 9/9 to 8/9 to get 17/9. So far, so good? Right, I'm going to go to Desmos and we are going to see if Desmos can help us, do this thing. Right, shrink this back There we go. Now, oh, excuse me. I need to go in and show you it, don't I? So we had, let me shrink that in a little bit because we need all the real estate we can get. The function we got was x to the power, and I hope it takes it as 9 divided by 8. Perfect. And the equation of the tangent line was 9/8 x take away 1/8. We were interested in the 0.11. So if I zoom in on this, is it going to help or make it worse? Can you trust me that that is definitely a tangent line? Would you agree? The curve and the thing, right? Now I'm going to put in the normal line. Now, shouldn't the normal line at 1,1 be pointing roughly in this direction here? You agree? Let's see if that's exactly what we got. Y equals negative 8/9 plus 8/9. Ah, isn't it nice when things work out the way you want them to? In fact, I'm going to hide this guy. Can you see the blue tangent line and the green normal line? Don't they look exactly the way we predicted? Right? Have we convinced you that this works then? Right? Tangent line the usual way. Now and again, they're going to ask you for the normal line. Any questions so far? Looking good? Okay. Then, you know, in some of these questions, I've been adding fractions and whole numbers or adding fractions to other fractions. Just to remind you how that would work. Suppose you had 8/9 and you wanted to subtract 1. If you go to your calculator, you can simply get it to do it. So to remind you how that works, negative 8/9 subtract 1. Then you hit the math button, choice number 1, and it turns it into a fraction. Yeah, there's the negative 17/9. So if you're having issues with your fractions, can't you use this technique, which is do the calculation and then hit the math button, choice number 1. Right, time to continue with some more examples. I think it's this one. It is good. Um, 28, nothing special. I'm not going to do that. 9/29. That's good. Hey, we have finished that section. There's nothing else I need to cover. So that gives us a chance to do an intro to the next section. So give me a few moments to get my act together. We're now going to be doing section. Lost the damn thing. 3.2. We are going to look at what are called product and quotient rule. Let me give you, these are basically formulas that you can use to find derivatives of complicated functions. Functions that are made up of 2 things multiplied, you'll use the product rule. And if it's 2 things divided, you will use what's called the quotient rule. And what that does is it allows us to find much more, as I said, complicated and weird looking functions and still be able to get the derivative. So here is, well, I'll tell you what this one's called. This is called the product rule. And basically, if your function can be written as 2 things multiplied together, right? Like f of x times g of x, then its derivative, y dashed, is f dashed x g of x plus f of x times g dashed of x. And we do not prove this to you. The proof of it is quite complicated. But if you go on and do advanced math, you'll actually one day see the proof of why that's the truth. But, you know, can we just believe it, right? Trust me, I'm a mathematician, right? It works. So that's called the product rule. Now the second one's called the quotient rule. And you use the quotient rule when your function is a fraction, right? F of x over g of x. So things like x squared plus 1 on the top and x cubed minus 1 in the bottom, right? Things that look like that. It's called the quotient rule you'd use. The product rule would be for things like x squared times e to the x, right? Two things multiplied. Now, for the quotient rule, the derivative is a fraction. It's f dashed g. Take away f of g dashed, all divided by g of x squared. We'll use a different color for that one. Again, we'll make no attempt to prove that that works. You're just going to trust me that it does work, right? So let's show you an example of a product rule. Right now, if I didn't tell you about the product rule, wouldn't that be impossible to do? You know how to differentiate x cubed plus 1, and you know how you differentiate e to the x. But the minute they multiply together, aren't all bets off? Isn't it now a totally new function? If you put it into a graph, you'd see it was quite different looking than either of the two bits. Now, what I do is until I get comfortable, I identify who the f and g are going to be. And when I write down the formula, I tend to miss the x's. I just write it like that. Are you comfortable that that's the same thing as this, but without all the x's? Just makes it easier to write a formula. Now let's see what we get then. What do you get if you differentiate x cubed plus 1? What's the derivative of x cubed plus 1?
3x squared.
Great. Times the untouched g, in this case is still e to the x. And f untouched is x cubed plus 1. And what do you get if you differentiate g? What's the derivative of e to the x?
B to the x.
Okay. Now, there are two rules to style points until we get to trig functions. Isn't rule 1 make it look like the original? And isn't rule 2 factor the heck out of it? Agreed? Can anybody see, in this question at least, how I might make it look a little bit nicer?
Combine the e to the x's to e to the x.
Okay, not that way, but couldn't we pull it out as a common factor?
Oh, yeah.
Would you agree that looks nicer? And you don't really need to do this, but I can't help myself. I have many idiosyncrasies, and one of my idiosyncrasies is that I don't like polynomials jumbled up. Would you agree x cubed plus 3x squared plus 1 is just on the eye a little bit prior, right? Would you ever lose points by doing that? No, technically it's correct, but to me it seems. I'm going to share